By the end of this video, you're going to understand what inverse kinematics is, how to set up your character with the animation rigging package to have them aim wherever your mouse is currently looking, and how to position your hands onto a gun using inverse kinematics. Hey, Chris here from LlamAcademy, here to help you.
Who? Me?
Yes, you! Make your game dev dreams become a reality by helping you understand inverse kinematics and how to have your player aim at a target with inverse kinematics. This has been something that I haven't really understood very well until I really dove in probably 2 months ago and started really understanding how does inverse kinematics work, how does animation rigging work, what tools are available to help you do this more conveniently. The way I implemented this in Llama Survival was very simple and kind of similar to what we've done so far in the gun series, where I just parented the gun underneath the player's object in front of it and then had the hands kind of just hover around the gun. And for the control scheme that I had for Llama Survival, that actually worked out pretty well because you're always facing directly forward. But as soon as we talk about maybe first person or third person controllers, that breaks down really quickly. Before we get too much into how do we set it up better, let's talk about how does inverse kinematics generally work, and then we'll get into how we're going to solve a particular problem. So like I said already, inverse kinematics is the process of choosing some point and working backwards from that point to position bones to reach that point. It doesn't have to be on a humanoid object, just that's what we're using in this particular case, is we have arm bones, leg bones, whatever. And we're going to be talking about this in the context of doing like a third person putting hands on guns. Unity gives us a callback called onAnimatorIK that is called anytime that script is attached to the same object as an animator. It allows you to set some parameters to the animator to set, hey, this is where I want the hand to be, this is where I want the elbows to be, this is where I want the feet to be, which is a key distinction. Whatever we're talking about right now is not a general inverse kinematics solution. It's specifically for humanoid type characters. So we can position where our hands or feet or whatever need to be, but we need to do something usually to figure out where should they be. This is why a lot of the times you'll see transforms positioned in the world, just empty game objects with only that transform. And those will be manipulated at runtime and say, this is now where I want this hand or foot or elbow or whatever to be. So that same concept of what I used in Llama Survival works pretty well here because we want to put the inverse kinematics targets underneath the gun. So as the gun moves around, the hands and arms will move around with it. Then we just need to choose a better location for the gun rather than just underneath the player's object, so it's always just floating around in front of it. Most likely we want it to be underneath the hierarchy or the bones of our player or our enemy, whoever's going to hold the gun, because as the character moves, the gun's not going to stay perfectly static in front of them. We want it to move with the animation of the player. That gets our hands and elbows positioned in some kind of reasonable way for a gun, but to have the player actually turn and aim wherever our mouse is aiming and wherever we see the crosshair on the screen, we need something a little bit more. This is where we're going to use the animation rigging package. There are other solutions like Final IK and that kind of stuff, but animation rigging is free. That's the easiest one for me to give to you in this repository. The animation rigging package allows us to manipulate the bones of a skinned mesh renderer or a skeleton while it's being animated and do something other than whatever the animation is trying to do. That's exactly what we need to have our character aim, because right now they're kind of just standing around and we bring up the hands. To install the animation rigging package, you can go to Window, Package Manager, and in the Package Manager window, you can search for animation rigging on the Unity registry. We're going to be using version 1.1.1 in this video. To set up our baseline, we first need to have our gun holder parented under the target bone. I had trouble if this wasn't the last sibling in the hierarchy, the animation rigging package got mad at me. So first we'll do this underneath the right shoulder. This is my preference because it moves a lot less than the hand and it can be more flexible if you have a limited set of animations. However, if you do have a good set of animations for all the styles of gun you want, on the hand may be a better option. I happen to have a rifle animation that I got for free from one of the Unity publisher sales, and it's a really nice mocap one. You can always find links to the latest sales in the descriptions of my videos. I also post links to sales I find particularly interesting in the community section of the channel. Unfortunately, this animation can't be included in the repo. It's not technically required. You can use some from Mixamo. I just found that this one was a little bit easier to get working the way I wanted it to. To get started, we'll select our animated model where the animator component is and go to Animation Rigging, Rig Setup. That'll attach our rig builder with a new rig, and we can see a new rig object is created underneath player armature. Something that's useful to visualize how is this rig configured is we can go to Animation Rigging, Bone Renderer Setup. Now we can see the bones for this particular rig. As long as you still have that player armature selected, it should automatically populate all these transforms and it should look correct. We'll get to how the hand placement was working in a little bit, but first, we probably want to handle aiming the body. The animation rigging package comes with a really nice component called the multi-aim constraint. This allows us to dynamically retarget a bone away from its current animation position and rotation to do something else. It's important to add these under the rig, and to know that if we have multiple of these, they're executed in the order they show up in the hierarchy. That'll be important in a minute as well. So we'll create a new object, and we'll call it spine aim, and we'll attach that multi-aim constraint. The constrained object is the bone that we want to manipulate, so we'll drag the spine to that, and it has an aim axis and an aim up. It's important to understand that the aim axis should be what is forward, or what should the blue be pointing to the characters forward. In this case, we have Z, the Z axis is a blue axis pointing forward, and Y, the green one, pointing up. That's the same, and by the way, up here at the top left, you want to make sure you have the local positioning handles. There's not much difference between these for this particular bone. Some of the future ones, it's going to be very different. So make sure you have local selected. So here we see the spine Z forward, Y up is perfect. So we'll leave those two alone. Now we want to tell it what should it look at. That's underneath the source objects. It's quite a bit easier to assign these in the inspector, but it is possible to assign them at runtime with a little bit of work. For today, we're just going to assign them in the inspector. So we'll add one object, and we'll also create an object that we want to move to wherever the player is currently aiming. We'll create a new sphere, call it aim target. I'm going to remove the sphere collider. And that's probably too big, so we'll make it maybe 0.1 scale and attach, I don't know, a material to the spatial mapping material. Cool. We'll get into how are we going to keep this where it's aimed properly in just a little bit. For the time being, we'll just position it over to the side and we'll see what happens to our model. Back on our spine aim multi-aim constraint, we'll assign that aim target. And we also have some settings here with a min-max limit of 180. That means it can basically turn any direction. I'm going to go ahead and constrain that to 45 degrees because at least I can't turn more than 45 degrees in either direction. And we'll see how that looks. Having a weight of 1 on our source objects is also great. We can adjust that later if we want to make it where it's less heavily weighted to aim directly at it. A value of 1 means it's going to look straight at it. A value of 0 means it's going to do nothing. Now we actually need more than one constraint because if we want our player to end up aiming at this thing, we need more than his spine just to look over there. So we're going to just duplicate this object, spine aim, call it upper chest aim, and we're going to drag that upper chest bone to the constrained object, and I'm going to leave everything else alone. Now we can see a little bit more. He's looking at this object. Great. We'll do it again for the head, so that way the head's actually looking at where he's going to aim. I'm going to do between the head and the neck. I think the head's the right one. And on each of these, you want to make sure that you're checking the axis. The head and all of these all still have Z forward and Y up, so we're good so far. So the next one I want to do is the shoulder, but I think it's better if we preview the actual animation we're going to use. So on a reload layer, I'm going to change this layer name to be called gun layer maybe. We're going to apply an avatar mask, so it's only affecting the upper body as well. And we'll just, in the animation folder, right click, create, avatar mask, call it upper body mask. And over here on the humanoid, we're going to disable all the stuff on the feet, legs, all that kind of stuff. So we'll select that upper body mask by clicking this gear, mask, upper body mask. That'll also fix the issue of when we're reloading, our legs are just kind of doing nothing. So we're going to want to play a different animation per type of gun, or at least different ways that you would hold a gun. So usually SMGs, submachine guns, rocket launchers, and even rifles are all held relatively the same. We can adjust the small little details of the placement of our hands and even our arms. So I have two bools, is two-handed gun maybe, and is one-handed gun. I'm going to bring in that animation from this rifle. We'll go to this new one in the case where is two-handed gun is true. And instead of exiting on reload, we'll come here only if is two-handed gun is true and after it has fully played, so if it has the exit time. I also pulled this pistol idle off our Mixamo, where you can see they're just kind of holding the pistol in front. I think that's good. It's called pistol idle. So hopefully that one works well for us as well. We'll do the same thing to make us go here if is one-handed gun is true after the exit time. This one should not have exit time. Okay, on our player armature now we can preview that. Great. Okay. Most likely this gun holder, we don't want it here. To minimize the offsets of each of these guns, I'm going to place it a little bit farther out in front. Most guns are going to spawn in front of our player. So we pick a position in front of the player, the offsets we have to apply are going to be smaller and a little bit easier to tweak. So if we pick this place, and we'll just drag in that machine gun again. That looks okay. If we move it over, something like that will probably be okay. Now we can preview the animation. It's a little bit better. In this preview state, I'm going to adjust. Looks like he's kind of aiming it up, so I'm not going to mess with that rotation for now. This looks like a reasonable spot. So I'm going to use these values for M4, and we'll adjust the pickup in a little bit. I think here's where we're going to do our right shoulder aim. We'll duplicate the head aim, rename it to right shoulder aim, target the right shoulder, and on this one, our axes are not the same as Z forward and Y up. If we select the right shoulder, so our right shoulder we can see is pointing Z backwards, so negative Z would be forward, and negative Y would be up, because Y is currently pointing down. So we flip this to negative Z and negative Y, that will make it where it orients it properly. If we place back our gun holder and machine guns, it looked like the gun was misaligned, and that's actually because my gun holder has some rotation applied. The 180 on the X is okay because it's making it point Z forward, but this kind of corrected to go forward. We don't want to have that anymore. So now we can see this gun looks like it's aiming directly at that target. I know the elbows are kind of ridiculous. That's okay. But we can see he's aiming at the target pretty closely, and he doesn't break his back or anything because of the constraints we've put on these. But that also means that sometimes he won't be able to shoot the target, which means we're going to also need to limit our camera because this obviously is wrong. Now let's see what we can do about these hands and these elbows, and also make it where our target will always be looking wherever we're currently aiming. The first thing I want to do is talk about the PlayerIK script. I put this together, I think it was in part 1 of the series, and didn't really talk about it or show it. Maybe I copy pasted and just splashed on the screen really fast and said, don't worry, we're going to talk about it later. Well, now is later. Hopefully you watched the beginning of the video when I talked about what is inverse kinematics and how does it work generally speaking. That's going to make it a lot easier to understand whatever we're about to look at here. We have 4 transforms here: a left hand IK target, a right hand IK target, a left elbow IK target, and a right elbow IK target. Really, the hands are the most important. The elbows are hints. They're a little bit less important, but still provide hints to the inverse kinematics solver whenever it's trying to place all of these limbs together. On animator IK is called every frame whenever the animator is calculating the inverse kinematics and doing the IK chain solving. The layer index is also provided on the animator IK, so if you only want to perform IK based on a specific layer, the callback can do different things with a switch statement or something like that on this layer index. The animator comes with some functions called set IK, rotation weight, position, and rotation. And then we have these enums of avatar IK goals, so we can place the left and the right hands at particular locations with particular rotations based on a transform. It doesn't have to be based on transform. We could use arbitrary vector 3s, but it's a lot easier to keep track of them with a transform component. It also allows us to set them up in the inspector. Because you'll notice we're using world space positions on these. We're not doing local position, we're doing the transform position and transform rotation. So this allows us to, in the editor, with the script, if it's attached to the animator that's calculating inverse kinematics, we can position 4 transforms relative to the gun that will bind the hands and the elbows to reasonable locations for a particular gun. And you can see the hints of the left and the right elbows do basically the same thing, but it's a little bit less nuanced. It just wants a hint position and a hint weight, which we can also control in the inspector via these amount variables that we have available. This works really well in combination with what we just did. It didn't work super well before, it worked okay, but you could tell if you didn't spend a lot of time positioning everything around really carefully, you'd get some bad results. And an important thing that you don't see here either is under our avatar IK goal, is there's nothing about fingers, which you might think what the heck, why do we care about fingers? A lot of the times, if you don't have animations already controlling the fingers that match really well to your models, your hands are just kind of sitting there flat next to the gun. They're not actually tied to the gun. You can handle this with the animation rigging, or there are some other assets that handle this, or you can just have animations that do it. This is a limitation to keep in mind, that at least the built-in Unity IK without animation rigging does not help you with finger IK. So here, in this particular case, we can see the left hand is a little bit higher than we actually want it to be. The left elbow is really high and kind of far out. Right elbow also really high and far out, but the right hand actually looks really well placed. So we take our machine gun clone, find the left hand, we can see it needs to come down. We can drag it down and we can reposition it. I'm going to disable the bone renderer. So we can position these wherever we want them to be, wherever looks good. Like here might be a little bit better. Find our prefab. We can even pause it, open up the machine gun prefab, find the left hand, and then just copy paste the values over. I locked the inspector on the in-game version, so I keep these values here so I can copy and then just paste the position. Now this has been updated. If we resume, we can find the left elbow. And we see here, it's really high. So if we grab that, just bring it down, maybe tuck it in a little bit, that looks a lot better. So we can do the same thing, lock the inspector, open up the machine gun prefab, copy component, left elbow in a new inspector window, paste component values, and it moves and we get a good result. And we can repeat that exact same process on the right elbow. This gun needs to be moved over some, and that looks pretty good. And don't forget to apply these transform positions to our scriptable object, so whenever the gun spawns, it spawns in the correct location. So on the PlayerIK, I don't think there's anything else to do. It already works perfectly for what we're looking to do. There's a little bit more cleanup we should do here in our player gun selector. Right now, whenever we're setting up a gun, we do some IK magic, and we're handling some IK within this script, which doesn't really make a lot of sense. This should really be a function of inverse kinematics. Before we do anything, I think it's important to talk about how are we finding these left elbow IK target, right elbow IK target, left hand and right hand. Notice that our do IK magic involves getting all of the transform children from the gun parent. So in this case, the gun parent is assigned to the gun holder that we spawn the gun underneath. And then we're looking for the child by name. So I generally don't like to do this, but for finding the IK targets, this ends up being one that I felt like that was a pretty easy one. Another option you can do is have a tag or a script assigned to each one and get component and children. That means under all of our guns, for each IK target, we need to have a transform with this exact name. So why don't we go ahead and get rid of this do IK magic and do something like inverse Kinematics.setup, where we'll do everything in this do IK magic over there. We'll define that public void setup on the PlayerIK that accepts the gun parent. We'll do all that exact same stuff and just reference our local variables instead of inverse kinematics. Since the PlayerIK also has the animator and the gun selector is the one that's going to be handling whenever we change guns, we have a couple options here. I think it might be cool just to add a second function, public void set gun style, that accepts a bool one-handed. We'll do animator.set bool is one-handed to one-handed, and set is two-handed to be not one-handed. Back on our player gun selector, right as we're going to set up this gun, we'll do inverse kinematics, set gun style to be, and I think we can simply do if the active gun type is the Glock. We may also want to defer whatever we do on awake to start, since we need some of the references to get set up in inverse kinematics before we start applying some of these things like setting up the active gun. If we hop over to the player action script, here we're already doing some raycasting from the camera to update the crosshair position, so it probably would be a good place to also putting that transform and having us aim properly. So at the top, I'll add a private serialized transform, aim target. Then if we look at update crosshair, we have two conditions. One is from gun, and one is if it's not from gun. From gun actually doesn't work very well, and that's because the inverse kinematics and the animation rigging are both trying to move the gun, but then we're using the gun to determine where the inverse kinematics and the animation rigging should be pointed. So there's two conflicting things trying to move based on one another, and that's making us get really weird, unpredictable behavior. from the camera, this works really well. So we want to do basically the same stuff here in the other case. So what I'm going to do is move that up here out of the condition because we want to do this. The raycast origin already comes properly, but we don't want the forward to be from the gun forward necessarily. It might be that it should come from the camera. So I'm just going to set vector 3 forward, declare it, and then check if our shoot type is from gun. If it is, we're going to do exactly what we did before. In the other case, the gun selector has a reference to the camera. We'll do gun selector camera transform forward. Since the raycast origin already considers the camera position, that's going to be perfect. So now we'll have a hit point either defined at an actual hit point or 10 units out in front of the tip point. Either way, regardless if we're shooting from the gun or the camera, we can set the aim target transform position to be this hit point. Let's see if that works. Remember, we have to assign that. So the player armature has player action. We'll assign the aim target. Click play, and now we see this thing moving around wherever our crosshair is. And our player is aiming exactly where this is going as well. So we need some left and right limits here because, well, still we haven't prevented this from happening, but at least in front of me, this works really well. The player still always aimed exactly wherever that point is, even though recoil maybe makes him miss. There's a lot of different ways that we can handle this. What happens if you go beyond where the player can actually aim? It's really a character controller thing. We can provide a little bit of guidance here maybe. In the third person controller, we can add something. Right now they clamp bottom and top clamp. We want it to be equivalent on left and right, so I'm just going to make a new public horizontal clamp and set that to be 90 by default, which is probably as generous as you want to get. A long time ago in the series, we also added something here where if you right click, it aims the camera wherever the player's forward currently is. We can get rid of that since we're now aiming wherever we're aiming and handling that with the inverse kinematics. A little bit further down, we have private void camera rotation. And in here, I think we can do an example of how you might be able to do something like this with your own character controller. We'll start with a quaternion rotation equals quaternion.look rotation from the transform forward. So that'll give us a rotation that is equivalent to the forward of the player. We'll get the Euler or Euler angles from that rotation, set a float min y to be the Euler angles y minus horizontal clamp, and max y to be Euler angles y plus horizontal clamp. And I had a lot of trouble using this clamp angle function that currently we're setting the sin machine target yaw to be. So instead, I'm just doing if the target yaw is less than min y, we're going to clamp it. And if it's greater than max y, we're going to clamp it and get rid of this previous line. This isn't perfect, but it gives you the idea of what we're trying to do here. I'm not sure this is the best way to handle this solution anyway, but it'll work for our demo at least. If you have any suggestions on better ways to handle it, I'd love to hear about that in the comments. We can see in this demo, as I go to the 90 degrees from forward, my mouse is stopped from moving over any farther. I can actually aim wherever I'm trying to move the mouse. These controls might be a little bit weird because now I have to move my character in order to keep turning. A lot of times it kind of rotates the player as well to keep it moving over that way. But again, that's more of a character controller issue. I don't want to really dive too deep into the nuances of controlling a player because then we'll be here all day. I know it took a while to put it together. Inverse kinematics isn't so easy that it just pops in. There is a lot of tweaking, manipulating transform positions, and just playing around with it to get it to look correct. But at the end of it, you can get some really nice, good looking results with very few animations. As you saw in this video, we have rocket launchers, SMGs, and rifles all using a rifle animation and just manipulating where the arms go, and it still looks pretty good. Really, we probably could have even used the pistol one and had all of them using a single animation. In the near future, I'm going to be looking at a lot of different IK solutions from free to $90 and see which ones make the most sense for you to use. We're going to be looking at animation rigging package, final IK, and some other really cool looking ones. That's going to be coming up pretty soon. If you want to make sure that you see that video, make sure you've liked and subscribed so you can be notified whenever that comes out. And if you want to support this channel, you can go to patreon.com/LlamAcademy or click join or super thanks right here on YouTube. Get your name up here on the screen. Get a shout out at the awesome tier like Autumn K, Matt Parkin, Ivan, Rulin, Iphiopolis, Dwarf, and Solar Int. And a super thanks from Tom. And at the tremendous tier, there's Bruno Bozic. And at the phenomenal tier, there's Andrew Bowen. Thank you all for your support. I am so incredibly grateful.